Check the model file. It has settings for global, ParticleN, FieldN, space, collision, and plot. Particle number, field number, space, collision, ePlot, and plot. In the initial .model file, let's take into account the global setting. It is possible to configure 5 parameters: particles, fields, gases, bolts, and actions. Let's consider each of them in turn. The first param is particles. It specifies the number of objects whose characteristics we will be able to describe later. The second parameter is fields, where the number of fields is also specified, which we can describe in more detail later. The third parameter, gases. Unfortunately, it is not relevant for configuration and will not be considered by us. When providing a description of the module file, we should set this parameter to 0. The fourth parameter pertains to bolts. Here we also need to specify the number of objects, particles, their characteristics, and interactions that we want to describe. The fifth parameter is actions. Here we directly describe the number of interactions between particles. Let's proceed to the remaining settings. The ParticleN setting is utilized for the purpose of creating n objects in the application. Earlier we created a number of objects. Now let's configure the characteristics of one of them. When defining a setting, you need to specify the ordinal number of the object, starting the count from 0. Proceed to parameters. The initial parameter is name. You must provide the name of the object. It can be absolutely any name you choose. The next parameter is charge. An object can be assigned a positive, negative, or zero charge. This feature enables the observation of interactions between charged forces. Next, mass. The object can have mass. The parameter takes mass in kilograms. Units of measurement are not necessary. Then set Rx to 0, set Ry to 0, and set Rz to 0. No specific units of measurement are required for these values. These parameters are used to make adjustments to the initial position of the object within the space, ensuring accurate placement and alignment in the given environment. Parameters Vx0, y0, and vz0 are responsible for the initial velocity of the object in space. Furthermore, you have the flexibility to modify the size of the object by adjusting the radius parameter, enabling you to customize it based on your precise needs and preferences. It is possible for you to assign a texture to the object, thereby enhancing its visual appearance and adding depth to its overall design. Here are examples of textures. Let's set the texture to apple. Color. You can modify the color of the object's track. You have the flexibility to choose nearly any color for it. For example, if you set 255, 0.0, track color will be red. 500 track also red. Type, object type. The classical type encompasses fundamental sections of physics, including mechanics, electrostatics, magnetostatics, and other key areas of study. Subsequently, radiation is the electromagnetic radiation emitted by an object due to its temperature and energy levels. The parameters trace and show name are responsible for displaying the track and name respectively. Graph. responsible for opening and displaying a window with a graph of the object's characteristics. The graph is described in the plot setting. Show velocity and show force options are used to adjust the display of the body's velocity vector and the force acting on it in the graph visualization. Setting field N or creating the nth field. Let's have a discussion about setting up field and its configuration. Earlier we created a number of fields. Here we will move on to describing them. Numbering also starts from 0. The initial parameter is name, where we specify the field's name during the process of naming the field. Next, it is necessary to describe the components of forces through which it will act on objects. We enter values into nuisance, parameters fx, fy, and fz. Within the parameters shift1, shift2, and shift3, it is possible to make adjustments to the initial position of the field by specifying coordinates. In coordinate, you have the choice to select the coordinate system. The options that are available are Cartesian, Cartesian and spherical, spherical. Modify the type, adjust the field type. You have the option to choose between G, gravitational field and electric field options. B represents magnetic field, K represents friction, EP represents electric potential, or BP represents magnetic potential. These abbreviations are commonly used in scientific and engineering contexts to denote these specific quantities and phenomena. Let's apply the selected parameters and look at the result. Now let's discuss configuring space. In it, describe the space. Take a closer look. In this particular field, you have the option to set the desired integration step for the process. Solver. This option enables you to choose the method for resolving equations, either Runge-Kutta or Yoshida, based on your preference. Flag collision. Specify if there will be collisions in your model. I'll demonstrate using an example of a ready-made model to help you understand. You and I forever united.
The subtitles were made by Dimitri, a skilled professional in the field.
As you can see, if you disable this setting, there will be no collisions.
Let's move on. Let us proceed. We should make our way now. Time is of the essence. Hurry up.
Animation scale, animation speed, that is the speed at which the model is rendered.
In the settings SX, SY, and SZ, you can set the scaling of the axes X, Y, and Z respectively.
Configuration of the axis. In this section, you can choose the coordinate system that best suits your needs. See,
you have 4 systems to choose from: XYZ, XY, XZ, and YZ. X, Y, and Z axes.
There are a total of 2 settings available: 2D axis offset horizontal and 2D axis offset vertical. 2 settings determine position of 2D coordinate system horizontally and vertically. Position specified by number. The following 2 settings, background image and background scale, set the background and its scale respectively. To do this, in the first field, specify the file name for background image, and in the second field, specify the scale by number. Settings background. Position X, Y, and Z determine background position along XYZ axes. Y, Z, and Z played position set determine background position on XYZ. The settings for camera X, camera Y, and camera Z respectively define the position of the camera along the X, Y, and Z axes. In order to specify coordinates, it is necessary to use numerical values. Coordinates cannot be expressed using any other form of representation. Next, we can configure the camera type by using the camera type setting option. There are multiple options. P. Perspective, indicating that closer objects will appear larger and distant objects will appear smaller. Or O. Orthographic, meaning the size of the object will not depend on the distance. Flag axis and color. Axis settings are responsible for display axes and their color. The color can be virtually any. For example, if you set 255, 0.0, the color of the axes will be red. 500 means the color of the axes will be red. The settings for flag grid and color grid are responsible for the coordinate grid, its display, and the color representation on the grid. Flag velocities and velocity scale settings are responsible for the display of velocity vectors and their corresponding scale. The same is applicable to both the flag forces settings and the force scale settings in the system. The finite difference setting controls the finite difference and is specified by a number. Modifying collision settings involves adjusting the parameters of the box, commonly referred to as the box. The box is a parallel pipette and can confine space. The objects themselves can collide with this box. Settings LX1, LY1, and LZ1 are used to define the minimum coordinate position of the boundaries along the axes. Accordingly, the LX2, LY2, and LZ2 settings indicate the maximum position of the boundaries along the axes.
Subtitles by Dima Torzuk. The switch setting allows you to indicate whether objects will collide with the box or pass through it. In the draw setting, you can specify if the box will be visible.
Plot setting controls graphics. You can adjust parameters in it to modify the visuals. Name X and name Y are responsible for labeling the X and Y axes respectively. In the Scale X and Scale Y settings, you have the option to specify the scale of both the X and Y axes. In color, set axis color. Entering 00255 makes axis blue. 55, then the axis will be blue. Next, let's consider the settings that allow you to indicate the position of the axes on the graph. Offset X, the position of the X-axis. There are 3 placement options available: bottom, center, and top. For the Y-axis, there are also 3 options in the offset Y field: left, right, and center, left, right, and center.